Welcome to 6.2 Law of Cosines Part 2. This will be short. We've got just a few problems to go through here. Hopefully you've seen Part 1. We talked about some of these things. We actually haven't really talked much about Heron's formula on Part 1, but we will be getting into that when we get down to problem number 40 in just a moment here. So this is the spot after Law of Sines and Cosines where they just throw triangles at you and you have to determine whether it should be Law of Sines, Law of Cosines. So let's take a look here. I'm going to draw a triangle. I don't try to draw these to scale. I always orient in this order, but here we have side A. I don't know why I put a 7 there. This is C. Side A is 10. Side opposite B is 12. And angle C is 70 degrees. And I immediately check and see, can I use Law of Sines on that? Of course, this is side, angle, side. So there would only be one solution on a side, angle, side problem. But Law of Sines works if I know an angle and a side opposite. But I don't know the side opposite this. I don't know the side opposite, the angle opposite that, or I don't know the angle opposite that. So this is a Law of Cosines problem. All right, angle A equals angle B equals, that's a terrible B. Angle C equals 70 degrees. Side A is 10, side B is 12, and side C we need to find. Now, if you set this up, even without the triangle, I can tell you we can't have Law of Sines here, because Law of Sines would be a proportion. It would be the sine of this on this equals the sine of this on that, and there'd be two unknowns. Or sine of this on this equals sine of this on this, and still we have two unknowns. So once again, it all comes down to you have to know an angle that's opposite of a known side to use Law of Sines. So if I call this side C, which it is, we can say C squared equals A squared plus B squared minus 2AB times the cosine of angle C. Or, so I won't rewrite that down again, or we could just jump to C, which we're looking for, equals great big square root of, getting rid of that squared, A squared, that's 10 squared, plus B squared, 12 squared, minus 2 times 10 times 12 times cosine of 70 degrees. So let's check out our calculator here and let's just go through that. So big square root, we've got 10 squared plus 12 squared minus 2 times 10 times 12 cosine of 70. Always worth double checking those, and I think we're in good shape there. And I hit enter and I've got 12.7-ish. We're going to round to tenths. And now I can Law of Sines. Now, we aren't in any jeopardy here, but Law of Sines, we skip to Law of Sines, and here's the story. If I was going to go for angle A, for instance, I'm going to use the 70, I'm going to use the 12.7 side C, and I'm going to use either the 10 for angle A or the 12. If I use the 10, take a look, I'm using side angle, and I'm giving Law of Sines an opportunity to lie to me. So typically, after we find an angle, after we find the first side on a side angle side, we're going to be finding an angle. We should find the small angle, in this case A, with Law of Sines, so it doesn't lie to us about an obtuse angle being acute. We've talked about that. So in this case, we're safe though, because 12.7 is the bigger. Should we jump to Law of Sines and do angle B first here, we'd be okay. But good practice would say, hey, use Law of Sines. If you've got an option of which angle to find the small one. So I'm going to go sine of angle A on 10 equals sine of 70 degrees. And I could put 12.7 here, but I'm running a little bit of a gamble. I want to use that value that's in my calculator. So I'm going to go on A and S. So angle A equals, I'm going to multiply 10 across times sine of 70 divided by our A and S. And then I have to get rid of sine with sine inverse of all of that. And that we talked about on the first, on the 6.1 section. So there's videos on that if you're having trouble following that. So let's clear this and let's go second sine inverse of 10 sine of 70. Close that and then divide by answer is located down here. It's second negative. So answer second negative. And I get 47.6 for angle A. So we'll fill that one in, 47.6 degrees. And now I'm going to go for angle B. So sine of B, side B is 12 on 12 equals sine of 70 degrees on, and now I can't use ants, I'm going to use the 12.7. I could reload ants if I wanted to, but 12.7. And let's go ahead, or yeah, that's what I want to do. Okay, and so now when we solve this, we get B equals sine inverse of 12 times sine of 70 divided by 12.7. Okay. Is that what I want? Yep, 12 times. So the only thing that really changed here was the 10 became the 12. And now I have to put 12.7 because this is my new A and S. Or I could go second enter, and now I could actually use A and S there. So now I can go ahead and change this with A and S. See, it's really easy to just backtrack and reload those. So let's go back to this one, and now my ants is good. I just want 10 to be 12. And I get 62.4. Okay, now the two tests that we go through that we should go through. Here's our big angle opposite the big side, little angle, little side, good, and 10 plus 12 is more than 12.7, and we're in good shape there. Okay, let's take a look at 38. I'm going to draw the triangle up here. Not trying to draw it to scale. A, B, C. We know angle C. We know side B. And we know side C, 25. And now this is a side-side angle problem, which means we may have a situation when we have side-side angle problems, we have situations at times where there's two different solutions. Now, the two different solutions comes from allowing law of sines to lie to us. And this is most definitely, we're going to start with law of sines here. So I'm going to go A equals B equals C equals little a, little b, little c equals. And I don't know A or A. I know side B is 19. I know angle C is 95 degrees. And this is 25. So law of sines, I can find B. The risk would be is might angle B be obtuse? We're in luck here. We know angle 2 is not obtuse because angle 2 is not as big, the side opposite, it's not as big as this side. And this angle is already obtuse. So angle B, since it's not opposite the biggest side, can't be obtuse. Law of sines isn't going to lie to us. There's just one solution. I'll come back and talk about that in a moment. So we can go sine of angle B on 19 equals sine of 95 degrees on 25. So B is sine inverse. I had to multiply 19 times sine of 95 degrees and divide that by 25. And I need sine inverse of all of that. So clear. 19 sine of 95, have to divide that by the 25 that was already there, and I get 49.2. Now, I want to go back and revisit this side-side angle. Because this is side-side angle, what we would normally do here, we would say, can the supplement of this angle, and the supplement of this angle is just about 131. Can 131 degrees coexist with 95? So does 131 plus 95, is that less than 180? If that's the case, then we have a whole nother triangle's worth of answers where angle B is actually 130.8. But in this case, we're in luck. So angle A, we're going to get angle A. That's the easy part. 180 minus 49.2 minus 95 is 35.8. And now we're going to get side A with law of sines. Little a on sine of 35.8 equals, I'm going to go down to here, 25 on sine of 95, because that's a little more accurate than this. The 35.8 is not quite exactly accurate, but we're in good shape here. So A equals sine of 35.8 times 25 divided by sine of 95. So sine of, let's clear this. Clear. Sine of 35.8 times 25 divided by sine of 95. And we got 14.7. And let's take a look. 14.7 plus 19 is more than 25. Check. Biggest angle, biggest side. Check. Smallest angle, smallest side. Check. I feel pretty good about it. Okay, now Heron's formula. And Heron's formula is this guy, and it's worth noting in Heron's formula. Okay, no big deal. Given any triangle with side length ABC, the area can be S times quantity S minus A, quantity S minus B, quantity S minus C, all under square root. It's worth noting this, that S is S because it stands for semi-perimeter. Oh, half the perimeter. Yeah, that's what we did. We added there's the perimeter of the triangle divided by 2. So, for this problem, just using Heron's formula, it's a side problem. And that's awesome because let's say you had this big triangular lot of land and you wanted to know what the area of that lot of land was. You wouldn't have to measure angles. You could just measure the distances and find the area in there. Pretty nice. You wouldn't have to drop a perpendicular to one side and do 1/2 base times height. We just have to know the dimensions of the outer dimensions of the triangle. We just need to know the perimeter. So in this case, we got a 25, a 35, and a 32, but the semi-perimeter is 25 plus 35 plus 32 divided by 2. Or 25 plus 35 plus 32, enter, divided by 2, 46. So our area is square root, S stands by itself first, 46. And then you have to take 46 minus 25, and 46 minus 35, and 46 minus 32. Probably the most common mistake made, other than not bothering to know the formula, is forgetting to put S by itself. You're not going to forget one of these. Okay, so we'll just do that on our calculator. Second square root 46 times, I think I'll do this in my head, 46 minus 25, 11, times 46 minus 20, that's why I shouldn't do it in my head, 21. 46 minus 35, 11, times 46 minus 32, 14, and we get 385.7, so it's approximately 385.7 square units. It's an area. Okay. Big assortment of problems here. Some of them are going to be pretty quick. Some of them are going to take some thinking. Let me know what we can help you with, and as always, stay tuned.